Good afternoon, everyone. In this tutorial, we're going to learn how to write functions within R. So a function is a task or a list of tasks that we predefine ahead of time so that we can do that list of tasks whenever we call that function without having to write everything out again. So let's look at an example of a function in action, something that we've already been using. So to get started, we'll create dfcars as a copy of mtcars like we have in the past. And we'll take a look at dfcars. And let's say I want to see the mean of the miles per gallon. So what that line is doing is it's calling the mean function. The mean function expects a list of values. I'm giving it the list of values of the miles per gallon field from the dfcars dataset. Then the mean function is taking that list of values, it's adding them all up, and then it's dividing by the number of values. That's how you calculate the mean, right? I didn't have to specify all of the things I wanted it to do with that list of numbers. That was already predefined as the mean function. So what we're going to do today is we're going to learn how to define our own functions so that we can do things this way. We'll come back over here. Personally, I find it easiest to define my functions up here in the source panel and then run them or do any other short-term things down here in the console, but do whatever works for you. We'll start off with something really simple. We'll create a function called hi, so you can see the syntax. We define it just like you define anything else with that arrow notation. Then to create a function, we use the keyword function. Then we have open and close parentheses. This is where we would put any input variables, just like how mean was expecting a list of values. If we were expecting any values, we could define them here. Right now, we're not going to do that. Then we put curly brackets, and whatever we write between these curly brackets is the list of tasks that we want to execute when we call this function. So to start, we'll go real easy. All we want to do when we call this function is return a string. Returning a value is going to print it to console, and all I want to return is a string that says hello world. Good classic example. When I run this, it's not going to execute the function yet. Right now we're just defining the function. If I want to execute the function, I want it to actually do this thing that I have now defined. I call it just like I would call the mean function, but now it's called hi, and we use the open and close parentheses. If there were input variables, this is where I would put them. And when I run that, it executes and it returns hello world, just like I told it to. So let's go ahead and make this a little bit more complex. Instead of saying hello world, let's say hello to our user. So now we need an input variable because we need to know who our user is. So I'm going to create an input called user, and I'm going to change our function. Instead of saying hello world, I'm going to put hello, comma, user. You'll notice hello is still in quotes because it's a string. User is not in quotes because it's a variable. And when I have something I want to return like this, where there are multiple parts, I can't use return. Return only wants a single argument. If I want to return something that has multiple parts like this, we use cat. Cat is short for concatenate. It means put these things together and then return it. So I'm going to run this. It's going to overwrite our hello function, or our hi function, sorry. And this is its new definition. If I try to call it the way I did before, hi, open and close parentheses with nothing in them, we're going to get an error. Because now it's expecting an argument, user. And if I don't provide it that, it can't run. So if I want this to run now, I have to tell it who the user is. In this case, I will put Kevin. Now when I run that, it says hello Kevin. That's exactly what we defined it to do. Very cool. Let's go ahead and take a look at how we can do some simple things using a numeric function. So let's say we want to create a function to convert from some amount of kilograms to some amount of pounds. So nice simple thing to do. We'll call this function kg to lb. And we're defining this as a function. We need an input here because we need to know how many kilograms we're converting. So I'll make an input and call it kg. and then we'll use curly brackets to define what we want to do when this function is called. So in this case, I could just return and then in the parentheses put the math that I want to do to give the value that I want to return. But instead, let's look at defining a local variable. So we're going to create a local variable here called LB for the amount of pounds, and we're going to give that the value of kg times 2.205. Then we're going to return LB. So the number of pounds that correspond to the input number of kilograms is kilograms times 2.205. I had to look that one up. Then we're going to return that number of pounds. So I'm going to run this, and it's going to create that function. Then to call it, just like before, we'll do kg to lb, and I'll input 20. So that's going to give me how many pounds correspond to 20 kilos. In this case, it's 44.1. And you could put any number in there. That's why it's useful to do this rather than hard-coding some value. We use an input variable so that we can return an output based on our input. Another important thing to notice is we don't, out here in our global environment, we don't have a new variable called LB with this value of 44.1. That's because this variable was defined within this function. It does not come out here to the global environment. It only exists within this function. So that can be useful to define things locally without cluttering up our environment. Okay, so that's how we can create functions that return strings. That's how we can create functions that return mathematic outputs of numbers. Let's look at a more complicated example of how we can use a function to return a value based on something within our data set. So let's say over here in DF-Cars, I have a friend who says, from this list of cars, I want to know which is the best car. Well, I would say, what do you mean by best? Do you mean the highest horsepower, the highest miles per gallon? What do you mean? And they would have to tell me, oh, I mean the highest horsepower, or whatever it might be. And then I could tell them which car has the highest value in that variable, right? So I could tell them which is the best car. So that's what we're going to create a function to do. This is a little bit more complicated than our previous ones, but before we get into it, let's think about how we would do this piece by piece, because if we try and do it all at once, it's going to be a little bit complicated. So the first thing we need to do is figure out which column they're talking about, right? If they say, I want to know which car has the most horsepower, we need to know which column they're referring to. So we talked about how you could look at the column names of a data frame with col names, and that's going to return the list of all of the column names in this data frame. If I want to know which column name matches with some certain value, I can check that by using the equals equals operator. So if I do col names of DF-Cars equals equals horsepower, we're going to get an output of a vector with a bunch of binary values. False, 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 true. That's because the fourth field is horsepower. The first three field names do not match with horsepower, so we get a false. It's the fourth one that does match, so we get a true. If we want to identify that by a number, we can wrap that whole line in a which. And what that's going to do is, instead of outputting this vector of binary variables, it's going to return us a number that tells us which column we're talking about. So now we know how to check when they say, I want to know which car has the most horsepower, we can check which column they're referring to. Okay, well that's cool. If I want to know which car has the highest of something, I can use max, right? So if I say max of DF-Cars MPG, let's say, that's going to return me the maximum value. If I want to know which car has the max, I do which.max, right? So which.max, that tells me the 20th car is the one with this highest value. So if rather than specifying the MPG, I wanted to refer to it by a column number, I could do that using bracket notation. So instead of saying MPG, we could use brackets. I'm not referring to a row, I'm specifying a column here, and I could say column 4. So now that's telling me car. Oh, before I was looking at MPG, now I'm looking at horsepower. Let's do 1 so we get that same output. So which car has the highest MPG? Which car has the highest value in the first column? It's car 20. So now if we put all that together, we can check which car has the highest value in any criteria they're looking for. But when I have this number, I don't just want the number. I don't want to say, oh, car 20. I want to give you the name of the car, right? So just like we could do column names, we can also do row names. So I can do row names of DF cars. That outputs the row names. If I do that, and then in brackets, I add a number, so let's say number 20, that tells me which car is the 20th. So we finally have everything we need. We can put all this together, and we can tell our friend which is the best car. So let's go ahead and create this function. So the best car is going to be a function. We need to know what is their criteria. That's going to be a field that we're going to search against to see which car has the highest value in that field. Now we're going to add brackets. So the first thing we need to know is which column are they talking about. For ease of use, we'll save this in a local variable. We'll call it c_index for column index. And we actually already wrote this. We know it is the which column name, except instead of specifically searching for horsepower, we're searching for which column has the equals the criteria, right? So which call names of DF cars equals criteria. Since it's a field name, not a string, we don't put it in quotations, right? So now we have that column number saved. We also know how to check which row we're talking about. We did that as well. So it's going to be, we'll save it as a row index to make our lives easier. So we'll say row index is going to be which.max of DF cars. So which row has the max value in DF cars of which column? Well, it's going to be column C index. So now we've saved the row number of the car with the highest value in the column of their criteria. Lastly, we just need to know which car is that talking about. So the car that's talking about is going to be row names of DF cars, and then index to R index. So that tells us what is the name of the car in that row name, or row number. And the last thing we need to do is return which car we're talking about. So I'm going to go ahead and run this and create this function. Now if I call best car, it's going to expect a criteria, and that criteria has to match one of these field names, right? So let's say horsepower. Uh-oh, undefined column selected. Let's see, I may have made a typo somewhere. And data.frame, DF cars R index. Ah, yes. Here we have to specify, I'm just looking for the row. Right, we're not looking for the columns. Let's try that again. Okay, best car based on horsepower is the Maserati Bora. If I want the best car by miles per gallon, it is our Toyota Corolla. And that's exactly what we see. If you want to manually check those, that's exactly what you'll find. So this is how we can create a function that is going into a data set and doing something kind of complex, right? we're taking a string that they give us, checking which column that refers to, finding the max value in that column, and then returning the name of the car that matches that max value, right? Okay, so there's some examples of how we can define our own functions. This does not even remotely cover everything you could do. We'll be looking at more examples of this in future weeks, but this shows simple example of how we can return strings and how we can accept input variables. Simple example of how we can define local variables and return numeric values based on some mathematical function of our input variable. And then a more complex example of how we can go and refer to a data set in some way based on our input variable. Right? But you don't always have to define every function that you're interested in using. Sometimes you'll find that people have already defined functions that you would be interested in. So if you come over here to packages, we've done this once before to pull out read Excel, but there's all sorts of predefined libraries of functions that people have created. So for this example, we're going to grab Dipler. Rather than just grabbing it here manually, I'm going to use the search. Oh, it's not gonna... If you're searching for something that isn't in the library, it will pull up a search menu to download it from their archive of these. So, but Dipler is already here. So we're going to grab a library called Dipler. Your exact text that you get returned to you might be a little bit different than mine. I have uninstalled and reinstalled things and done all sorts of funny things here. Dipler has a ton of predefined functions to make data manipulation easier, ways to refer to different fields, to select certain fields, all sorts of things. If you click on it here, you can see all of these functions that are predefined here. Dipler is nice in that they also have some really nice web documentation. I'll link that to you as well. But just to show an example here, I haven't defined this function, but it was defined in Dipler. So we're going to use the function between to return all the rows of our data set with some field between two bounds that we set. That's really useful. That would be a little bit more complex to write ourselves, right? So let's say I want to see values from, let's do horsepower between 100 and 150, let's say. So I'll do DF cars, horsepower. Then I ask you for the left bound, I'll set at 100, and the right bound I'll set at 150. When we run that, you'll notice this should look familiar to when we were checking if our column names matched some particular input. This is a vector of binary values, right? So all I have to do is set this to an index, or any vector name really. Oh, darn it. And then I can pull from DF cars, and I want to reference all the rows that are included in that index and all the columns. And here's a list filtered to just see the cars with a horsepower between 100 and 150. Right? So you don't always have to reinvent the wheel. Sometimes the functions that you're interested in have already been written somewhere.